Alright, these are solving equations that have a variable. So, in this situation, what you want to do is get the letter alone on one side of the equals and get the numbers on the other side. So I've written up here strategies to use when you're starting any one of these problems. First, you want to try to move numbers without variables, meaning the numbers that are alone, they don't have letters attached. Try to move those first. And then anytime you're moving, and what I mean by move is you're moving a number or a letter to the other side of the equal sign. And anytime you're doing that, you do the opposite function to move the number. So if 2 is added, then you subtract on both sides to move it across the equal sign. And so let's just demonstrate that in these examples. Here you have -3 equals 9 plus a number we have to solve. Well, what number, if you add it to 9, will equal -3? Sometimes just talking it through, you would know the answer. But we're going to do the steps to isolate the variable. So in this situation, the letters added to 9. So what we're going to do is move the 9. You do the opposite to bring it here. You subtract 9. 9 is added, so you subtract 9. So then on this side you would have a 0, and you subtract 9 here. Well, this isn't normal subtraction. You have a negative integer. So you have to do the rules for integers. You don't just subtract. You change all your subtraction when you're using integers to addition. And that means you add the opposite. You have to change 9 to its opposite. So now you have -3 plus -9, which is -12. So 9 has been subtracted from both sides. You still have this f here. So you bring that down. You have f. The 9 is gone. You have the equal sign. And you subtracted 9, which is really adding a -9. And you have -12 equals f. That problem has been solved. So let's circle that answer. Alright. Now on this one, -4s equals -48. Here you have a letter, number, number. Here you have a letter, a letter, number, and a number. But in this situation, -4 is multiplied by s. So in order to take those apart so that 4 is there, or so that the s is there by itself, you have to do the opposite. -4 is multiplied, so you have to divide -4 by both sides of the equation. Always do the opposite to both sides to keep it balanced. So remember, any number over itself, you have -4 over -4 times the s. Anytime you have a number over itself, it's equal to 1. That equals 1. So it then becomes 1 times s. So you simply cancel out that -4 in that way, and you're left with an s. So you have s equal to -48 divided by -4. The answer is 12. And then you look, well, what I divided 4 and 48, but let me look at those integers of dividing by a negative and into another negative. So when you have a negative on the numerator and a negative on the denominator, the answer is positive. Remember, for multiplication and division, when you're multiplying the same integer, you get a positive. When you're dividing the same integer, you get a positive. So s equals 12 in this situation. And then over here, remember what I wrote up here. You're moving numbers without variables first. So mess with, as you were, or as it were, mess with the numbers that are by themselves first. So I'm going to move this 4. I want to get it over here to this side. Get it get it away from the 17z. So this 4 is subtracted, so I will add the 4 to both sides. And you're combining like terms. So you're just going to add the 4 to the other number without a letter. So negative 4 plus 4 is of course 0, and that was the goal there. We wanted to make that 0. And then the difference, if you follow your integer rules, you have a negative and a positive and you're adding. So you find the difference and take the sign of the larger number. So the difference is 32. And so you have a negative 32. 36 is larger than 4. Because remember, when you're thinking this way, you're sort of ignoring the negative sign when you look for the larger number. You're looking for the larger of the two. What's larger, 36 or 4? 36. Okay. So you have 17z. That's still there. Let's use a different color. I'm bringing that down from the problem because it's not gone from the problem. I've gotten rid of the 4. I still have an equal sign. Let's bring that down. And I've changed this. Negative 36 has become negative 32, and I still have the 13z. So I need to bring that over here. Still part of my problem. And that. So we have 13z minus 32. Alright, so now we started with moving numbers. Now because we have letter here, we need to get the letters on the same side. So we're going to move the 13z. So we take a look at that, and it is a positive 13z, so we do negative 13z minus the 13z, and that will be 0, and then minus 13z. If you think in terms of integers, you're adding the opposite, and in this case you can subtract, so you don't really have to bother. So that is 4z equals, no, we still have the equal, we have a 4z now, and we still have this negative 32 over here. So we write that down. We have now 4z equals negative 32. So this thing, it starts getting difficult to see. This is not a 2, this is the letter z. So we have a 4 times a z. Our last step is going to be division then. So we will do 4z divided by 4, because we do the opposite to both sides of the equation, and we'll have negative 32 divided by 4. Four over 4 is 1, because any number over itself is 1. Then you have 1 times z, so you just end up with z equal 4 into 32 is 8. You have a positive number on the bottom and a negative on top, and so when you're dividing a positive and a negative, you get a negative. So then your answer, let's make that a little more clear, z equals negative 8 for number 31. Those are those 3 problems.